In this video, I am going to discuss about the law of conservation of linear momentum and the Newton's second law is what here real law. It means the Newton's second. Why the Newton's second law is called the real law? Because by using the Newton's second law, we can prove the Newton's first law as well as the Newton's third law. So first one, what is the law of conservation of linear momentum? According to law of conservation of linear momentum, in the absence of external force, the total momentum of a system is remain constant and does not change with time. अगर किसी सिस्टम पे एक्सटर्नल फोर्स न लगाया जाए तो उस सिस्टम का जो टोटल मोमेंटम रहेगा वो हमेशा क्या रहेगा, टाइम के साथ कांस्टेंट रहेगा. जैसे फॉर एग्जांपल व्हेन वी फायर ए बुलेट फ्रॉम ए गन, तो बुलेट को फायर करने के लिए जब हम गन यूज करते हैं तो उस बुलेट पे हम एक्सटर्नल फोर्स नहीं लगा रहे हैं, बट व्हेन द बुलेट इज फायर्ड तो बुलेट तो फॉरवर्ड डायरेक्शन में जाएगा किसी वेलोसिटी से. बुलेट के पास मास है, इसके पास क्या होगा, मोमेंटम होगा इन द फॉरवर्ड डायरेक्शन. एंड सेम अमाउंट ऑफ द मोमेंटम इज एक्सर्टेड बाय द बुलेट ऑन द गन इन व्हाट डायरेक्शन, बैकवर्ड डायरेक्शन. क्यों? बिफोर फायरिंग टोटल मोमेंटम जीरो, सो आफ्टर फायरिंग द मोमेंटम ऑफ दिस बुलेट एंड गन शुड बी आल्सो इक्वल टू जीरो. क्यों? क्योंकि यहां पे हमने कोई एक्सटर्नल फोर्स नहीं लगाया है. Same way, you can say, suppose if you will consider or if you take a bomb, कोई बम है रेस्ट में है, तो रेस्ट में जब है तो उसका टोटल मोमेंटम क्या है, जीरो है. लेकिन जब ये बम एक्सप्लोड किया सपोज टू इक्वल पार्ट्स में, तो when the bomb will explode in the two equal parts, then both parts will fly off in the with the same velocity in the opposite direction. क्यों? क्योंकि पहले पार्ट का जिससे जो मोमेंटम हो और दूसरे पार्ट का जो मोमेंटम हो दोनों इक्वल होगा, और क्योंकि डायरेक्शन अपोजिट है जिनका सम फिर कितना हो जाएगा, जीरो. तो टोटल मोमेंटम बिफोर एक्सप्लोजन ऑफ द बम एंड टोटल मोमेंटम आफ्टर एक्सप्लोजन ऑफ द बम इज व्हाट हियर सेम. सो इन दिस वे यू कैन से when there is no any external force is acting on a body, then total momentum of the system is remain constant, which does not change with time. Now, Newton's second law is called what law? Real law of motion. Real law of motion means by using the Newton's second law of motion, we can derive the Newton's first law as well as the Newton's third law. So, first one, Newton's first law derived from the second law. Means, how can we derive the Newton's first law of motion by using the Newton's second law? Let a body of mass m, and when a force F is applied on it, suppose the body is gain the acceleration what here a. मान लो कोई बॉडी है जिसका मास m है और उसके ऊपर हमने फोर्स F लगाया, तो उस बॉडी का एक्सीलरेशन कितना हो गया, a. Then according to Newton's second law of motion, this force F is equal to mass into acceleration. F is equal to m into a. And now you remind what is the Newton's first law of motion. In the absence of external force, or simply you can say if the body is in rest, then it will remain in rest. If the body is in motion, then it will remain in motion unless or until an external force is applied on it. It means if there is no any external force, it means if F is equal to 0, अगर हम उस बॉडी के ऊपर कोई फोर्स न लगाएं, so if the external force F is equal to 0, if this force F is equal to 0, then you can say this 0 is equal to mass into acceleration, और बॉडी का मास तो 0 होगा नहीं, it means its acceleration is equal to what here, 0. And if the acceleration of the body is 0, then there is two possibilities. Either the body is in rest or body is moving with uniform velocity. इसलिए हम कहते हैं if the body is in rest, it will remain in rest, and if the body is in motion with the uniform velocity, then it will move with the same uniform velocity unless an external force is applied on it. So you can say, in this way you can say we can derive the Newton's first law with the help of the Newton's second law. Suppose Newton's third law derived from the second law. How can we derive the Newton's third law? By using the second law. Suppose two body A and B collide with each other. मान लीजिए दो बॉडी A और B है, एक दूसरे से क्या करते हैं, कोलिजन होता है उनमें या कोलाइड करती है. Then during the collision, both body will be exert a force on each other. And suppose the force on A due to B is FAB toward this one. and FBA is force on B due to A towards this one. It means the force on A and B is FAB and FBA. FAB means force on A due to B, and FBA force on B due to A during the collision. And suppose both body is collide, or this collision takes place, or both body is collide for a time delta t. So force on A and B is how much? Force on A is FAB and force on B, what is here? FBA. Time for the collision is delta t. And suppose the change in momentum during this collision, change in momentum of A is delta P1 and change in momentum of this one is what here? Delta P2. Or B is what here? Delta P2. And all of you know, impulse is equal to change in momentum. You know, impulse is equal to change in momentum. And impulse is what? Impulse is the product of force and time for which that force is act on the body. Since during the collision both body is in contact for a time what? Delta t. So the impulse of this first body, you can say here impulse is equal to. So when we use this formula, impulse is equal to change in momentum. So for first body A, impulse product of force on A for what time? Delta t. FAB, already I have told, force on A due to B. So FAB is force on A due to B. So impulse is FAB into delta t. And what is the change in momentum of this A? Suppose delta P1. And similarly, the impulse for the B, FBA into delta t is equal to delta P2. And since during the collision, whole system will be act is a one system. And during the collision, no any external force is acting on these bodies. So by the Newton's second law of motion, there sum of the moment or the total momentum is remain constant. So you can say here delta P1 plus delta P2. This should be 0. क्यों? क्योंकि ड्यूरिंग कोलिजन नो एनी फोर्स इज एक्टिंग ऑन इट हियर. कोई बाहर से कोई फोर्स नहीं लग रहा. And if delta P1 plus delta P2 is equal to 0, it means you can say FAB into delta T plus FBA into delta T is equal to 0. When you will take delta T common, you can say here FAB plus FBA, and this one is delta T is equal to 0. From here you can say FAB plus FBA is equal to 0, or FAB is equal to minus FBA. And in this way you can prove what here? Newton's third law. If for every action there is equal and opposite reaction. So force on A due to B is equal to force on B due to A, and both are acting in one direction, opposite direction. So in this way, by using the Newton's second law, we can derive the Newton's first law as well as Newton's third law of motion. Due to this reason, Newton's second law of motion is what law? The real law of motion. So next topic is use of Newton's second law to determine acceleration in some practical case. And under this first, block placed on smooth horizontal plane. Smooth horizontal plane means in this case I am not taking the friction between the body and surface on which the body is placed. हम फ्रिक्शन को नहीं ले रहे हैं. जहां भी स्मूथ सरफेस दिया हो, इसका मतलब उस बॉडी जो रखी गई है और जिस प्लेन पे रखी गई है उनके बीच में कोई फ्रिक्शन नहीं है. तो इन दिस केस सपोज अंडर दिस फर्स्ट ब्लॉक प्लेस्ड ऑन स्मूथ हॉरिजॉन्टल प्लेन, अंडर दिस फर्स्ट केस force F is applied horizontally. Suppose this one is a plane surface, horizontal plane surface, or you can say here a smooth horizontal plane, this one. and a block of mass m, any block of mass m is placed on it. कोई ब्लॉक जिसका मास m है इस सरफेस पे रखा गया है. Then you know the weight of the body is mg, and that weight of the body is always act in what direction? Downward. It means this block will apply its weight mg in what direction? Downward. तो ये mg फोर्स जो इस ब्लॉक का वेट होगा वो इस प्लेन पे लगेगा किधर? डाउनवर्ड डायरेक्शन में. तो इसको हम अगर एक्शन मान लें तो ये प्लेन सरफेस भी इस ब्लॉक के ऊपर क्या लगाएगा? एक रिएक्शन फोर्स. किस डायरेक्शन में? अपवर्ड. अकॉर्डिंग टू न्यूटन्स थर्ड लॉ ऑफ मोशन, फॉर एवरी एक्शन देयर इज इक्वल एंड अपोजिट रिएक्शन. तो एक्शन भी फोर्स है, रिएक्शन भी फोर्स है. तो वेट इज ए फोर्स. So the weight of this block mg will act downward on this plane surface in the downward direction, and this plane surface will apply a reactionary force on this block in what direction? Upward direction. So this one is called normal reaction, and this one is called the weight of the body. And suppose a force F is applied like this. तो now if anybody asks to you कि how many force is acting on this body, इसके ऊपर टोटल कितने फोर्स लग रहे हैं? तो there are the three force. One, weight of the body mg. Second, normal reaction r, and third is applied force F. And suppose in this case the body moves in this direction with the acceleration a. मान लो हमने जब फोर्स F लगाया तो बॉडी क्या कर रही है? ए एक्सीलरेशन से मूव कर रही है. अब आप ये देखिए, इवन थ्री फोर्सेस आर एक्टिंग ऑन दिस बॉडी. तीन फोर्स इस पे काम कर रहे हैं, लेकिन ओवरऑल ये बॉडी का एक्सीलरेशन किसके डायरेक्शन में है? केवल अप्लाइड फोर्स इसके डायरेक्शन में है. इसका मतलब इस नॉर्मल रिएक्शन फोर्स का मोशन के लिए कोई भी जिम्मेदारी इसकी नहीं है. मीन्स this normal reaction is not responsible for this motion. This mg is also not responsible for this motion. तो भैया ये करेंगे क्या दोनों जब ये कर रहे हैं? इसका मतलब r and mg both will be balanced to each other. ये एक दूसरे को क्या कर देंगे? बैलेंस कर देंगे. So you can say here in this case r is equal to mg. r is equal to mg. It means r is equal to mg का मतलब क्या हो गया? ये ब्लॉक जो नॉर्मल रिएक्शन है और ये जो वेट है ये दोनों क्या करेंगे? एक दूसरे को बैलेंस करने में चले जाएंगे. अब बचा ये फोर्स F, एंड सिंस द एक्सीलरेशन इज टेकिंग प्लेस इन द डायरेक्शन ऑफ F, तो आप कर सकते हैं व्हाट इज द रोल ऑफ दिस वन. यू कैन से नाउ दिस फोर्स F according to Newton's second law of motion is equal to mass m into acceleration a, and in this way you can say a is equal to F by F. तो आप देखा करिए कि हमारे एक्सीलरेशन वाले डायरेक्शन में कितने फोर्स काम कर रहे हैं, और वही नेट फोर्स जो एक्सीलरेशन के डायरेक्शन में काम करेगा दैट विल बी इक्वल टू मास इनटू एक्सीलरेशन बाय यूजिंग द न्यूटन सेकंड लॉ ऑफ मोशन. तो इस केस में अब देखिए, अगर r बड़ा हो गया होता mg से तब क्या होता? अगर r mg से बड़ा हो जाएगा तो बॉडी ऊपर होने दी जाएगी. अगर mg बड़ा हो जाएगा r से तो ये नीचे चली जाएगी. लेकिन ये बॉडी ना तो ऊपर गई और ना तो नीचे गई. इसका मतलब इसका और इसका कोई काम मोशन में नहीं था. Only this force is responsible for producing the acceleration, are responsible for the motion. So you can say F is equal to m8 or A is equal to m by m. In same way here also, actually this one is what here I am taking two cases. This one is pulling force and this one is what force? Pushing force. And here also weight of the block will act downward, normal reaction upward. When we apply this force F, suppose the body moves with the acceleration A in this direction. तो इसका मतलब फिर यहाँ पे क्या है? ना तो बॉडी ऊपर जा रही है ना तो नीचे जा रही है. इसका मतलब R और mg दोनों एक दूसरे को क्या कर दिए? बैलेंस कर दिए. And now this force is responsible for the motion of this block. Suppose the mass of this body is m, so you can say this force F is equal to ma. So A is equal to F by m. So even three force is acting on this block. But out of these three forces, two forces is balanced to each other, and only one force is responsible for the motion of the block. And in this way, you can find out the acceleration. In this case, when a block is placed on a smooth horizontal surface and we apply a horizontal force on it. So today you go through this topic here, what I have discussed, and in the next video again I will give some more cases here regarding to this use of the Newton's second law to determine the acceleration. Thank you.